Hey everybody, 3.10 implicit differentiation. So implicit differentiation is a way to differentiate an equation that has more than one variable in it, and the variables tend to be mixed together, whereas most equations are y equals, and then all of the x terms are on the right-hand side. So as a warm-up, I just want to list all the ways that we can notate the derivative of a function. So most commonly, we've been comfortable using y prime or f prime of x if it's in function notation. We tend to stay away from dy over dx, df over dx, and d dx. Now they're all saying the same thing, it just depends upon what the original equation or function is named as. Y prime is the same as dy over dx, f prime is the same as df over dx, and if you just have a d dx, that means we're deriving an expression with respect to x. The denominator is, of course, the important, it's the variable that we are deriving with respect to. And that's what we're going to start to see change in this implicit differentiation section. Okay. So just as a quick review, find the derivative of each, ln of 4x. So that's that u prime over u rule that we talked about. So then you end up having 4 over 4x, which will simplify to 1 over x. The reason it does this is because of logarithmic expansion, right? This is equivalent to ln 4 plus ln x. Well, ln 4 is just the constant, and therefore when we derive ln 4 by itself, it would go to 0, leaving us with just ln x to derive. Okay, the second one, we have a couple things going on here. So I want to remind us that we need to rewrite the log base 4 into an ln. The division of ln 4 could be pulled out. So it's just a coefficient of the ln of 3x squared. Okay, so now what we're looking at is a product rule. And the product is x cubed is the first term, and 1 over ln of 4 times ln of 3x squared is g, the second term. So f prime g plus fg prime. So y prime equals 3x squared. It's up to you if you want to write it as the log base 4 as the original or the change of base formula. It really doesn't matter because we're keeping it the same. Plus x cubed stays. And when we derive the 1 over ln to the 4th times ln of 3x squared, 1 over ln to the 4th remains as a coefficient. And then the ln of 3x squared goes to u prime over u. So 6x divided by 3x squared. This is something that we, of course, can simplify. The first term is going to stay. I'm going to write it back as the log base 4. And the second term, well, we can reduce it quite a bit. If you take a look, the x cubed that's out in front can combine with that 6x. So we really have a 6x to the 4th over a 3x squared, which would reduce to a 2x squared, and divide by that ln 4. Okay. So here's a look at the type of equation that we're going to be differentiating this section. Okay. So I want to do a quick explanation of the notation and the importance of it. Okay, I'm not going to actually derive this y to the 4th plus xy currently. I'm going to leave it. But I want to talk about what's going to happen when we derive y terms. So to differentiate these functions, we need to use a process called implicit differentiation. And in order to do this, our job is going to be to focusing on those y terms. Anytime you derive a y, I want you to think of it as a chain rule. Right, let's just use the y to the 4th. It's not really x to the 4th, right? So then we would say that it's something other than x, because we're still deriving these equations with respect to x. We're still doing dy over dx. Okay? So therefore, when we're deriving a y to the 4th, we're thinking of it as something to the 4th, which is a chain rule. So something to the 4th always goes to 4 something cubed times something prime, right, inside prime. What is my inside? Well, it's y. So I could write this as 4y cubed times y prime. But my argument for why I don't want to keep it as a y prime is really the notation is too nice and pretty, right? We would easily make the mistake that this is equivalent to 4y to the fourth power because the prime mark looks like a first power. But that's incorrect. What I want you to acknowledge, remember the notation that we warmed up with, y prime is no different than having dy over dx. So 4y cubed y prime is 4y cubed dy over dx. Now dy over dx sticks out like a sore thumb. There's no chance that we're going to mix together or combine y cubed and dy over dx. They're saying different things. Okay, so in summary, anytime you derive a y term, you have to apply or attach or multiply, whatever word you want to use here, dy over dx, because of the inside prime, right? It's something other than x. So therefore it's a chain rule and we need that inside prime. Okay, so let's take a look at our first example. So our implicit differentiation, there's 3 steps. Differentiate each side with respect to x. Apply the chain rule when differentiating the y term. So attach dy over dx. Okay. Finally, solve for dy over dx. Our final answer should say dy over dx equals everything else. Okay, so derive both sides with respect to x. So any x terms, they derive normally. So x squared becomes 2x. Y squared, we're thinking of it as something squared. So it goes to 2 something something prime. Okay, well that something prime is a y. So 2y dy over dx. Right, so all power rules, product rules, chain rules, all of those rules continue as they normally would. But if it's a y that you're deriving, attach the dy dx for the inside prime. And this is equal to 0. Okay, cool. So we've derived, we've applied the chain rule. Now we just have to solve for dy over dx. So we subtract 2x and we divide by 2y. And you can simplify this to negative x divided by y. Okay. Here's the next example, which was the same one that I didn't fully derive before in the introduction, but I'm going to do it now. Okay, so y to the fourth. Well, that's a y term, so we think of it as a chain rule. So y to the fourth would be 4y cubed, attach a dy dx, plus. Now right here is the most common mistake in this section. We miss the product rules all the time. So x times y is a product rule. We need to use f prime g plus fg prime. So x prime is 1, y stays, plus x stays, y prime is 1 dy over dx, equals 3x squared minus 1 plus 0. Okay, so we've derived it, we've applied the chain rule, now we need to solve for dy over dx. Here there are 2 terms that have a dy over dx in them. So we're going to first keep the dy over dx terms on the left and the non-dy dx terms to the right. Okay. The next step would be to factor dy over dx out of those terms. And finally, divide by 4y cubed plus x. And that's your final answer. Oops. Where'd I go? Here we have e to the x times y equals sine of y squared. So careful, there's chain rule, there's product rule here, there's implicit differentiation. So on the left-hand side, we have a chain rule. The outer is the e, the inner is the x times y. So with the e, we're thinking e to the u goes to e to the u times u prime. Okay, so e to the xy would stay, and then we need to multiply by x times y prime. Okay, I'm just going to indicate that. I'm going to do one step at a time here. Equals. Here's a second chain rule on the right-hand side. Sine of y squared. So the outside is sine, which goes to cosine. The inside is y squared. And we still need to derive the inners. Okay, so in this case, I set up my chains. I derive my outers. I've indicated to derive my inners. And now I'm going to do the next step. All right, okay, so we have product rule of x times y. X goes to 1, y stays, plus x stays, y derives to dy over dx, equals cosine of y squared derives to 2y times dy over dx. Right, if you derive a y, attach a dy dx. Okay, so now I have dy dx in two places. I need to distribute in order to get to them, though. So I have y e to the xy plus x e to the xy dy over dx equals, I'm going to put the 2y out in front of the cosine, right? It cannot combine with that y. Sorry about that. Dy over dx. Okay, so now I can see my dy over dx terms. I'm going to actually move those to the right. And then I can factor them out. And then finally divide over. So dy over dx equals y e to the xy. Divide by 2y cosine of y squared minus x e to the xy. Okay, here's another one. This one has an ln. Every time we see an ln with a chain rule, ln u goes to u prime over u. Okay, so x squared plus y squared becomes 2x plus 2y dy over dx. Divide by x squared plus y squared. Right, there's my u prime over u. And that equals 1. All right, now just isolate your dy over dx. So I'm going to multiply by x squared plus y squared. Subtract 2x and divide by 2y. I'm going to leave these three for you to try, and we'll go through them in class together. Pause the video, write them down, fill them out, and we'll talk about it when we see 3.10 in class. But I do want to do the equation of the tangent line. Remember, I said that this type of problem is going to constantly come up. So we have y to the fourth plus xy equals x cubed minus x plus 2. And now we want to find the tangent line to the curve at 1, 1. Typically, with these problems in the implicit, the entire point is given. So we just have to find the slope. Okay. Now, this was the exact problem that we did earlier, so I am going to go through it again, but I'll do it a little bit faster. So y to the fourth, 4y cubed dy over dx, plus product rule. X goes to 1, y stays, x stays, y goes to dy over dx, equals 3x squared minus 1. Isolate your dy over dx. I'm going to move the non-dy dx terms to the right and factor out the dy dx terms from the remaining. And then divide by 4y cubed plus x. Okay, so now I want to know what the slope is at the ordered pair 1, 1. So x has become 1, y has become 1. So we have an answer of 1 over 5, and that is our slope. So we have our point, we have our slope, and now we easily have our line. Y minus 1 equals 1/5 times x minus 1. Okay, so that's it for this lesson. Problem set's posted in your module, and we'll go through plenty of examples in our Zoom class together. Okay, take care.